Good morning, students. Today we are going to see conditional probability and multiplication theorem on probability and independent events. So first we are going to discuss about conditional probability. For that, I'll consider an example. A fair die is rolled once. So this is the example we are going to take, and we are going to discuss about the answer for two questions. The first question is, what is the probability of getting an odd number which is greater than 2? Okay, if a die is rolled once means the sample space is 1, 2, 3, 4, 5, 6. Okay, so the n of s is equal to 6. Here, what is the probability of getting an odd number which is greater than 2? So here in this, what are odd numbers? 1, 3, 5. So here our question is the odd number which is greater than 2. So what are the odd numbers will come? 3 and 5. So therefore n of a is equal to 2. So and n of s is 6. So the answer is 2 by 6, that is equal to 1 by 3. Coming to the second question, if the die shows an odd number, then what is the probability that it is greater than 2? So there is a difference in the first and the second question. If the die shows an odd number, so already the die showing the odd number. Okay, so this event, the die shows an odd number, we have to take it as A means A is already happened. Then you have to find the probability that it is greater than 2. So the odd number is greater than 2 is nothing but B. So already one event happened. Then we are going to find on that condition we are going to find the probability of another event. Here what happened? The die shows an odd number. So what are the odd numbers will come? 1, 3, 5. So any one of the three will come. Okay, so if on this we have to find the probability it is greater than 2. So it is greater than 2 means what has to come? 3 and 5. So therefore this n of a1 is equal to 2 by 3. Why it is 3? Here only we are taking the odd number. We are not going to take all the outcomes when a die is rolled once. We are not going to take the outcomes 1, 2, 3, 4, 5, 6, because here it is one condition is given. What is that? The die shows an odd number. So therefore our sample space is restricted to the odd number only, that is 1, 3, 5. On that condition we have to find the probability that it is greater than 2. That is 3 and 5 has to come. So the answer is 2 by 3. So here the conditional probability of an event B, assuming that the event A has already happened. Okay, A event, two event, one is A, another one is B. Idhila event A has already happened and we are going to find the conditional probability of an event B. It is denoted by P of B by E. The denominator இருக்கிற event ஏற்கனவே நடந்திருக்கும். அந்த conditionல we are going to find the probability of B. So it is P of B by A and is defined as P of B by A is equal to P of A intersection B divided by P of A. What is that? P of A intersection B divided by P of A. So the P of A should not be equal to 0. The same way, in another way, the conditional probability of an event A, assuming that the event B has already happened. B has already happened. On that condition, we are going to find the probability of an event A. So it is denoted by P of A by B. That is also P of A intersection B divided by P of B. Okay, so the next one, multiplication theorem on probability. So from that conditional probability definition, we can find P of A intersection B is what? It is P of A by B into P of B. That also you can write P of A by B into P of B. Otherwise, P of A intersection B can be written as P of B by A into P of B. Okay, P of A by B into P of, here what has to come? A by B into P of B. Here P of B by A into P of A. Okay, so P of B by A into P of A. So this is the multiplication theorem on probability. Okay, so see now here P of B by A is what? P of A intersection B divided by P of B. Now P of A intersection B is needed now. Your answer is P of B by A into P of B. The denominator la what you are having, that has to written here. So P of A by B into P of B, or otherwise P of B by A into P of A. That is the multiplication theorem on probability. Next one, we are moving to the independent events. The events are said to be independent if the occurrence or non-occurrence of any one of the event, okay, does not affect the probability of occurrence or non-occurrence of the other events. ஒரு ஈவெண்ட்டோட occurrence non-occurrence does not affect the probability of the occurrence or non-occurrence of the event. Okay, so it does not affect the probability. Okay, so those events are called independent events. You see that two events A and B are said to be independent. Rendu event independent na if and only if P of A intersection B is equal to P of A into P of B. In the multiplication theorem, we have said that P of A intersection B is equal to P of A by B into P of B. Here, if the two events are independent, means P of A intersection B is equal to P of A into P of B. Okay, because they are independent means the occurrence of one event does not affect the probability of another. So therefore P of A by B is equal to P of A, and P of B by A is equal to P of B. Okay, it does not depend on the probability of the another one. So the next one, A1, A2, A3, etc. An are all independent events mutually. Okay, அப்போ P of A1 intersection A2 intersection A3 etc. intersection AN is nothing but P of A1, P of A2 etc. P of AN. So here we have written only for two independent events. Here n number of independent events comes if P of A1 intersection A2 intersection A3 etc. intersection AN is equal to P of A1, P of A2 etc. P of AN. So see now the theorem. If A and B are independent, A and B are independent means A bar and B bar also independent. A and B bar are independent. A bar and B bar also independent. Okay, so now we are going to discuss the independent property with mutually exclusiveness property. So independent events is a property of probability. Depending on the probability only we can decide the independent events. But mutually exclusiveness is a set theoretic property. Okay, so if the two sets are given, we can easily say where they are mutually exclusive or not. But independent events, after finding the probability only, we can say the two events are independent or not. So independent events is a property of probability, and mutually exclusive events is nothing but a set theory property. Independent events can be identified by their probabilities. So on using the probability only we can identify the independent events, and mutually exclusive events can be identified by their events. On பார்த்த உடனே சொல்லிடலாம் they are mutually exclusive இல்ல. So common element இருந்ததுன்னா they are not mutually exclusive. If we have independent events can be identified only by the probabilities. Okay, if A and B are mutually exclusive, they cannot be independent. If A and B are independent, they cannot be mutually exclusive. These are the results based on independent and mutually exclusive property. So we are coming to exercise 12.3, the second problem. If A and B are two events such that P of A union B is equal to 0.7 and P of A intersection B is equal to 0.2 and P of B is equal to 0.5, then show that A and B are independent. So we have to show A and B are independent. So the independent events depends on the, it's a probability theory. So we have to find the probability. So if two events are independent, what the answer we have to write? P of A intersection B is equal to P of A into P of B. If we show that result, we can say the two events are independent. So first here, what is given? P of A union B. So we know that addition theorem on probability, the P of A union B can be written as P of A plus P of B minus P of A intersection B. So what is P of A union B? It is 0.7. P of A, we don't know, we have to find it. P of B is given, that is 0.5, and P of A intersection B is minus 0.2, that is 0.2. Here in between you are having minus, so it is. So 0.5 minus 0.2 is 0.3. So when you bring it to the left side, it is minus 0.3. So 0.7 minus 0.3 is 0.4. So we have found P of A is equal to 0.4. So what we have to prove? We have to prove A and B are independent. So for that we need this result. So first you take P of A into P of B. That is, P of A we have found is 0.4 and P of B it is given that 0.5. If you multiply, your answer is 0.2. So 4 5s are 20, and if you move 2 places, it is 0.2. So what is 0.2? 0.2 is nothing but P of A intersection B. So we have proved the result. P of A intersection B is equal to P of A into P of B. So if this condition happened, we can say very well A and B are, what is it? They are independent events. And coming to the third problem, if A and B are independent events such that P of A union B is equal to 0.6, P of A is equal to 0.2, find P of B. So here what is given? A and B are two independent events. So two independent events means P of A intersection B is equal to P of A into P of B. Okay, here also P of A union B is there. So we take and write the addition theorem on probability. What is that? P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A union B is given, that is 0.6. P of A is 0.2 and P of B only we have to find out. And if P of A intersection B, so they are independent events. So P of A intersection B can be written as P of A into P of B. So this 0.2, when you bring it to the left side, it is minus 0.2. So when the answer is 0.4. Coming to the right side, from these two terms, P of B is common. If you take it out, it is 1 minus P of A. Here P of B is taken out. Here you will have 1. So if you, from this term, if P of B is taken out means here minus P of A. So P of A value is substituted here. What is it? 0.2. So 1 minus 0.2 is 0.8. Okay. So bring this term to the denominator. So 0.4 by 0.8. So the answer is 4 by 8. 4 by 8 is what? It is 1 by 2. So we have found P of B is equal to 1 by 2. Otherwise you can write it is 0.5. So we completed the third problem. And coming to the problem number 4. If P of A is equal to 0.5, P of B is equal to 0.8 and P of B by A is equal to 0.8. Find P of A by B and P of A union B. Okay, so you take the result first, P of B by A. So how you can write multiplication theorem on probability, or it's a conditional probability. From the definition of conditional probability, how you can write? It is P of A intersection B divided by P of A. Okay, so P of B by A is given, that is 0.8. And P of A intersection B we don't know, and P of A is what? 0.5. When you multiply these two, 8 5s are 40. So if you remove, if you place 2 decimal places, you will get the answer 0.4. So we have found what it is, P of A intersection B. And what is asked? P of A by B. How you can write the definition of the conditional probability? It is P of A intersection B divided by P of B. Okay, P of A intersection B is what? It is 0.4. What is P of B? It is 0.8. It is given here. Okay, so the answer is 4 by 8. That is 1 by 2. That is also 0.5. So this one 0.5. Next, what is asked? P of A union B. Use the addition theorem on probability. P of A plus P of B minus P of A intersection B. So we know all the results. P of A we have found, isn't it? P of A is given, that is 0.5, and P of B also given 0.8. P of A intersection B only we have found that is 0.4. So 0.8 minus 0.4 is 0.4. If we add it with 0.5, the answer is 0.9. Okay, coming to the problem number 5. If for two events A and B, P of A is equal to 3 by 4, P of B is equal to 2 by 5, and A union B is equal to S. So that means if you add the two events, if you join the two events, you will get the sample space. So find the conditional probability of P of A by B. Okay, so see now, P of A by B, what is the formula? P of A intersection B by P of B. Okay, but what is needed? P of A intersection B. So for that, what is the result is given? A union B is equal to X. So we just apply, find the probability. Probability of A union B is equal to P of S. So S is the sample space. We know that the total probability is 1. So therefore P of S is equal to 1. So in the starting probability class we have studied this. P of A union B, they are two events. Okay, so therefore addition theorem on probability, P of A union B can be written as P of A plus P of B minus P of A intersection B. So P of A is what? It is 3 by 4. P of B is 2 by 5 minus, okay, this one, when you bring it to the left side, it is minus 1. Here minus P of A intersection B, when you take it to the right side, it is plus P of A intersection B. On this, we have to take LCM. The LCM is 20. So here you will have 4. So it has to be multiplied with 5. So the numerator also has to be multiplied with 5. 3 5s are 15. Here, when you take LCM, it has to be multiplied with 4. So 2 into 4 is 8. So here, it is 1 into 20 is 20. So 15 plus 8, what has to come? It is 23. 23 minus 20 is 3. 3 by 20. That is your P of A intersection B. After finding P of A intersection B, you have to substitute in the formula. P of A by B is asked. So P of A by B is equal to P of A intersection B by P of B. What is A intersection B? That is, probability of A intersection B is 3 by 20, and P of B, it is given, that is 2 by 5. So if you reciprocate in the denominator, it is 5 by 2. And what has to come? This 5 and 4, 20 is getting cancelled. So therefore 3 by 4 into 1 by 2. So the answer is 3 by 8. And coming to the next problem, that is problem number 10. So given P of A is equal to 0.4 and P of A union B is equal to 0.7. Find P of B. So these two results are given and you have to find P of B under each condition. Okay, so take the first condition. If A and B are mutually exclusive. If an A and B are mutually exclusive means, what is P of A union B? That is P of A plus P of B. P of A union B is given, that is 0.7. P of A is 0.4. From that you can easily find P of B is equal to 0.7 minus 0.4, that is P of B is equal to 0.3. So first subdivision is over. Next one, A and B are independent events. So A and B are independent events means we know only result P of A intersection B is equal to P of A into P of B. Okay, so first I will consider the given result P of A union B. How we can write? P of A plus P of B minus P of A intersection B. So P of A intersection B can be written as P of A into P of B. Why? A and B are independent events. Okay, so you substitute P of A union B is what? 0.7 and P of A is what? 0.4. These two are given. From these two that is terms, P of B, if you take it out, here you will have 1 minus P of A. So what is P of A? It is 0.4. So this 0.4 we can take it to the left side as minus 0.4. So 0.7 minus 0.4 is equal to P of B into 1 minus 0.4 because P of A is 0.4. So if you substitute here, 1 minus 0.4 is 0.6 and 0.7 minus 0.4 is 0.3. So bring this 0.6 to the denominator. So it is 3 by 6, that is 1 by 2, or otherwise it is nothing but 0.5. So second subdivision, if A and B are independent events, we have found P of B. And the third one, P of A by B is equal to 0.4 is given. What are the two results already given? P of A is 0.4 and P of A union B is equal to 0.7 mean, and one more result is also given. P of A by B is equal to 0.4. Find P of B. So we know that P of A by B is equal to 0.4. This is given. P of A by B, what is the formula? Using the definition of the conditional probability, P of A intersection B divided by P of B. Because we don't know P of B as well as P of A intersection B. We know only two results. What are the two results? P of A and P of A union B and P of A by B. That's all. Okay. You take P of A union B again. So what is it? P of A plus P of B minus P of A intersection B. Okay. So P of A, you bring this P of A intersection B to the left side, it will become positive. Bring this P of A union B to the right side, that is minus P of A union B. So we see now P of A, what is it? 0.4. P of B we have to find out, and P of A union B is given as 0.7. What is 0.4 minus 0.7? That is minus 0.3. Okay, so we got the result P of A intersection B in terms of P of B. So you just substitute this result in 1. In the place of P of A intersection B, what will you write? P of B minus 0.3 in the numerator. In the denominator, what do you have? P of B, that is equal to 0.4. So cross multiply. So P of B minus 0.3 is equal to 0.4 into P of B. Okay, bring this term to the next side. So what has to come? P of B minus 0.4, P of B is equal to 0.3. Okay, so from these two terms, in the left side terms, P of B, if you take it out, it is 1 minus 0.4. What is 1 minus 0.4? That is 0.6. Here in the right side you will have 0.3. So you need P of B. So it is 0.3 divided by 0.6. That is 3 by 6. 1 by 2. That is equal to 0.5. And coming to the fourth one, P of B by A is equal to 0.5. Okay, so P of B by A is equal to 0.5 means what is the definition of the conditional probability? P of A intersection B divided by P of A. So P of A intersection B we don't know, but P of A is given. What is it? It is 0.4. If we multiply these two, your answer is 0.2. So what we have found? P of A intersection B. So P of A union B, you take it. P of A plus P of B minus P of A intersection B. Because what is asked? P of B only we have to find out. P of A union B, it is given in the problem, that is 0.7. And P of A also 0.4, it is also given. And P of B we have to find it. And P of A intersection B we have found just now, it is 0.2. Okay, so 0.4 minus 0.2 is 0.2 plus P of B. You need what? P of B. So P of B, you keep it in the right hand side. Bring this 0.2 to the left side as minus 0.2. 0.7 minus 0.2 is equal to 0.5. That is your P of B. Thank you, students.